In this video, we're going to talk about the different gases that make up our atmosphere, what kind of concentrations we can find them in, and where we might expect to find them. When we're talking about the air in our atmosphere, it's just a mixture of a bunch of different gases found in differing amounts. And when we look at our atmosphere, 78% of it is made out of a gas called nitrogen. Nitrogen isn't really something that we breathe in as humans. We care a lot more about oxygen, which makes up 21% of our atmosphere. Together, nitrogen and oxygen make up 99% of our atmosphere. So that means that 1% is every other gas that we have here on our planet. So our third largest component to our atmosphere is a gas called argon, which is 0.9%. And then the rest, the 0.1% of our atmosphere, is every other gas. We're going to talk a lot about greenhouse gases in this chapter and in several other chapters this semester. These greenhouse gases are the ones that trap heat in our atmosphere and are currently causing our planet to warm up and causing our climate to change. With this, carbon dioxide is one of the most important greenhouse gases. It's majorly affecting our climate, but it's found in incredibly tiny amounts. When we look at the overall contribution of carbon dioxide in our atmosphere, it makes up only 0.04%. So it's a very small trace amount of our atmosphere, but it's having a really significant impact on our planet right now. So even though these greenhouse gases are making up such a small fraction of our atmosphere, the reason why they're so important is because they're really good at absorbing heat. Think about trying to sleep at night. I like to sleep with a blanket. It helps keep me comfortable. Without the blanket, I'm not going to sleep super well. I need at least one to help keep me warm. So we need some greenhouse gases on our planet to help keep us above freezing. But if I keep adding more and more blankets to my bed, I'm going to start getting warm very quickly. So now let's imagine that I've taken my one blanket and I've quadrupled it. Now I'm sleeping under 4 blankets. Now, because I have increased the warming potential, those blankets are going to warm my body more. I'm going to warm up more quickly. So we're seeing that as we're increasing these greenhouse gases in our atmosphere, it's warming up the planet. They're just really good at absorbing energy and keeping things warm, just like a blanket is. But one of the issues is that every single day we're adding more and more of these greenhouse gases into our atmosphere. This graph is showing us the carbon dioxide concentrations in our atmosphere since the 1960s. You'll see that we started off just below 320 parts per million, and today we're actually at 423 parts per million. So the amount of carbon dioxide is really rapidly increasing. So that's like I'm just adding a blanket to my bed every other week. It's going to get hot really, really fast. But there's another greenhouse gas that we don't talk about as much, and this is water vapor. Water vapor is just telling us how much gaseous water is stored in our air. And overall, it's about 4% of all of the volume of the air in our atmosphere. It's going to be the things that form our clouds and what will eventually condense and form our different forms of precipitation. While water vapor is natural and we absolutely need it to survive, it's also a greenhouse gas. And here, as our planet warms, we're going to have more evaporation of our oceans, which is going to increase the amount of water vapor in our atmosphere. And just like adding another blanket to our bed, it's going to help warm up the planet, which will cause more evaporation, which will increase our humidity, and it's just going to create this continuous loop. And there are 2 other important parts of our atmosphere. One of these is called aerosols. And aerosols are tiny particles that are either solid or liquid. And with these tiny particles, it's going to allow other things like water vapor to condense around it. So a lot of times these aerosols are going to be condensation nuclei. And we're going to talk about this in other chapters. It's going to allow condensation and eventually precipitation to occur. But aerosols can also reflect sunlight. It can cause issues with the color of our sky. It could be a bad thing if we have too many aerosols in the air, but it can also be a good thing. The reason why it looks like our sky is changing color at sunrise and at sunset is because at this angle of sunlight, we can actually see all the aerosols in our atmosphere that are reflecting light. So the reason why we see orange and purple during sunrise and sunset are all due to these very, very tiny particles in our air. And we can see these aerosols moving in satellite images. Here we can see all of the dust, all of the tiny solid particles that are moving off the Korean Peninsula. But another thing that I want to mention about our atmosphere is a gas called ozone. And ozone is just made of 3 combined oxygen atoms. So its chemical formula is O3. And ozone is really good in our upper atmosphere. When it's high above the ground, it acts like a sunblock. It prevents really harmful UV radiation from making it through the upper atmosphere towards our surface. So it's going to act like sunblock and protect us from UV radiation that could give us things like sun cancer. But if ozone is found along the ground where we are, this is a carcinogen. So for ozone, its distribution is not uniform. It's found in different layers of our atmosphere in differing amounts. Most of it is found between 6 and 31 miles above the surface. This is where it's really beneficial and acts like a sunscreen. It's absorbing that harmful UV radiation, and it's helping protect all forms of life at the surface. But one common misconception I see a lot with students and with ozone is they think that ozone is a greenhouse gas. Ozone is preventing UV radiation from moving through this layer of our atmosphere. It is not trapping in heat like a greenhouse gas.